Hi, and welcome to this new video series on C++ programming. The purpose of this series is to be a introduction to C++, primarily geared towards those people who are taking my course on Unreal Engine 4 programming. In Unreal Engine 4, one of the most powerful features is C++, and so instead of diving directly into Unreal Engine C++ programming, I want to give an introduction to the basic ideas and syntax and capabilities of C++. Inside the engine itself in Unreal 4, we will be dealing with some constructs that are very specific to Unreal Engine 4. And if you're not familiar with C++ itself, the additional constructs can be a little bit confusing. We're going to cover some of those ideas here and show how they work later in this series, but we're going to start off with the basics of C++. I'm working here in Visual Studio. This is Visual Studio 2019. So this is the URL, and I'll put the URL for this download site in the description of this video. You can download Visual Studio 2019 Community Edition. It's free, and start using it immediately. One note, when you do this, you will want to pick certain packages. Because I already have multiple versions of Visual Studio installed, it's not going to let me show you that. But you want to be sure to select C++. You'll see that there are groups called workloads that you can select. You can click the checkbox on them. Be sure to install C++. You can install other workloads that you might be interested in as well, but at the very least install C++. I already have this project open, but I'm going to close this and create a new project. We'll go here, File, New Project. The first time you run Visual Studio, you will see this Create New Project panel. What you want to do is select C++ in this drop down. You can see that I have many workloads loaded, so I have different languages. We want to select C++. For our purposes here, we want to select Windows. If you're working in some other environment with Visual Studio, I can't be sure what that would be. It's probably Windows, even if you're on a Mac or something. You would be in the Windows mode, but I don't know anything about Apple products, so I'm working in the Windows environment, and what we want to select for the type of project here is console. And what you'll see here shows up in this list. These are just filters that filter out the stuff that's in here. So this is everything that meets those basic requirements. What we want to select is a console application. Be sure that it says C++, Windows, and console at the bottom, and click Next. I'm going to change this project location here slightly to here. Select that folder, and I'm going to call this CPP_tutorial TUTORIL 1. Not a very creative name, I know, but we're in these early ones at least. We're not going to write anything special. So once you've got your location set, we want to create a new solution. Be sure this is off so that it creates a new project directory for your whole project. So all your files will be in a single project directory. We'll click Create, and it's going to go through a little bit of process here to create the project. It's generating some initial code, and I'll give you a quick tour of Visual Studio, but we'll really go through, we're not going to use a whole lot of the capabilities of this tool, just mainly what's on the screen, and I'll describe most of those capabilities as we go through some, but there's some basics you want to know about. You've got the main editor screen here. Down here at the bottom, you may not have as many of these panels open as I do, and that's okay. I've customized or turned on many different things, but there'll be windows down here at the bottom that'll tell us different things, and output is one that you'll see, which will give the compiler output, and the error list will list your errors if there's any errors in your code. And I'll show you that. We'll create some errors intentionally so that we can see how to do things. Okay. Over here on the right is my Solution Explorer. This has a variety of folders here in source files. This is where all of our actual source files will be. These header files and resource files are actually not, they look like folders, but they're actually filters. And I'll go into that a little bit. It's a way of organizing it without them being in separate subdirectories. They can appear in those filters. So our main source file that it created is called cpp tutorial1.cpp, and it filled it in with this little hello world program and some comments. We can run this program. You'll see here in the comments it says you can run the program by pressing Control plus F5, or debug start without debugging menu, or you can debug the program with F5 or debug start debugging. So let's take a look at that. Here's the debug menu, and you'll see you've got these, here's the debug menu, and you'll see you've got these two starts, start debugging or start without debugging. That's what that's talking about. Or we can press F5 to debug. So I'll do that. I'll press F5, and it's going to start the program in debugging mode, and there it is. It says hello world, and it pauses. The program is actually terminated, but the window is held open, so we can close that. Or we can just go up here, and where it says local debugger, we can pull this down. There's a variety of different ones. There's web service debuggers and remote debuggers. We want the local debugger. We can just hit that, and it'll run it as well. And that's really the easiest way to do it, is just come up here and hit this arrow and run the program. All right. So let's talk about C++ and what it is and what it's all about. So it's a programming language. It's a language that is compiled directly to the platform that we're running on, meaning the C++ compiler itself does not run in any kind of the C++ compiler produces machine code that doesn't run in any kind of a framework. It runs directly on your hardware within your OS, and there are certain aspects of it that has to be connected to or linked to a particular OS. That's why we have different compilers on different OSs. So this is the Microsoft compiler for the Windows operating system, is in Unix. The most common one is the GNU GCC compiler. At some point in time, I might do some Linux C++ programming, which will be a little bit different, but for now we're going to be working in Windows. In order to compose a C++ program, you have to start, if the program is going to be an executable that you can run and not a library — we'll talk about libraries later — you need to have this main entry point. The main entry point is not actually the true entry point of the program, but for our purposes as programmers, it is. There's actually one other entry point that the operating system uses in order to configure things for that particular program, and that's all set up by your compiler, and you don't have to worry about it. The name of that particular function is the _start function. You only have to worry about that function if you're an operating system developer. Otherwise, for our purposes, the main function is our entry point. This is where our code that we're going to write begins running, and it runs the code in this, and when this main function exits or returns, the program terminates. Now, Microsoft did a couple of good things here, and they did one kind of bad non-standard thing that I'm going to correct right now, is that a main function in C or C++ really should always return a value. The C++ standard has a main function that doesn't return a value, is an undefined state for the exit of that program. So we really should always return a value from the main function. Returning 0 means that it returned normally. And there are header files you can use and some codes, words that you can put in here for different things. But if you return a non-zero value, it means that your program exited with errors in some way. And it just informs the operating system that the program terminated abnormally. This is more critical in some ways in the Unix environment than it is in the Windows environment because of the way we use programs with shells and other such things where the exit of a program may control actually the flow of an external script, such as a bash shell script or something. In Windows, that's less critical. There's not as much of that going on handling these return values, but we really should do that. Now, what's this particular program saying? Well, we do have our main function. That's our entry point. We are now returning a value, and we're calling this. And we saw when we ran it that just printed out hello world. Right there. Hello world. That's what it printed out to the console. How did it do that? Well, we've got a couple things going on here. We're including a file called iostream. Now, you've probably heard of header files. They've been around a long time. They're part of the C standard. They're also part of the C++ standard. They're the way that you tell your program about interfaces to other library functions or to stuff within your own program. It's a way of describing or declaring what you're doing. In this standard library here, that is the C++ standard library, all of the header files in that standard library are just a file name with no .h. This is in the C++ standard. It tells us that if it's in the standard namespace, and that's what this standard is, it's a namespace, and we'll talk about namespaces shortly. Just for now, think of a namespace as a place like a bucket that has a name that says everything in this bucket starts with this name, whatever the name of that namespace is. In this case, the name of the namespace is std, standard. Anything in that standard library, which is what C++ ships with for the most part, is going to include files that don't have a .h at the end of them. For backward compatibility with C, there are still some header files that do end in .h. If a header file ends in .h, you can be assured that it's from the C programming language, not the C++ programming language. This current standard has all of these C++ header files not ending in .h, but only for the standard namespace. If you're creating your own header files, you can end them in .h or in .hpp if you prefer. I prefer to just use .h. That's a personal preference. It doesn't matter as long as you stick with a consistent way of doing it. There are some reasons why you might use a combination of .h and .hpp for personal organizational reasons. I prefer not to, and we'll get to that later. So this include statement is called a compiler directive, and it's telling the preprocessor that runs prior to all of this being compiled to include this file, iostream. Now there's no path attached to this, and that's because the compiler is configured and knows where to find all the standard library stuff, and anything that's on that particular set of paths where it can find it is surrounded by these angle brackets, the less than and greater than symbol. When used around something like that, they're angle brackets rather than less than and greater than. All right, those less than and greater than tell the C++ preprocessor that they're going to look in special directories for that. When you create your own header file, you will put the name in quotes, and that'll tell it it's only looking for that file within your local file structure where your program resides. So iostream is a standard library, C++ standard library, that contains various things regarding streams. And cout is one of those. And cout is the stream that goes to what's called standard out, Standard out is what prints to the console that we just saw printing hello world. And we use in C++ this special stream operator. Now, you may have seen this in other contexts. Possibly it's a shift left operator, shifting bits to the left. Well, one of the beauties of C++ is operator overloading. And this has been a standard overloaded operator for a long time when working with streams. And what it says is take whatever on the right-hand side of this operator and send it into whatever's on the left-hand side of this operator. And what's on the left-hand side is an output stream to our console. So this whole statement is saying this. It's saying, go out and look in the standard namespace, which we've included a part of using this iostream include. Find this cout stream that's defined within that namespace and send to it this string hello world ending in a slant n. Now, there's another thing about this particular statement that I don't like, and this is a pet peeve, and it has to do with portability. I don't like using this. There is a special thing in our standard namespace. I'm going to type, I'm going to do operators again. I'm going to type standard : end L. Regardless of what ends a line in what operating system, end L is portable. End L will send the proper line ending for the operating system your program is running on. And this would be the standard way of doing this. Instead of embedding a carriage return or line feed or anything else in a string, it's better to send this end L to this stream. So now we've got two of these pipe operators, and this is the beauty of them. This is in some ways akin to functional programming. This is a complete expression with two operators in it. This expression is run, and this string is sent to cout, and that function that does that returns cout, so that this whole thing becomes just cout, and this end L is sent into cout as the return value. Mathematically, this is the equivalent of putting parentheses around this whole thing, but you don't have to put parentheses around it because of the nature of this is left associative. So that means it's going to do this one first, combine these together, return the value, which is this cout, which is a reference to an object that handles that stream, and then it's going to send this to the return value of what happened here. So that left associativity means we don't have to put parentheses in here. If for some reason we were to put parentheses in here, well, let's run this first of all and make sure it works. Hello world. I'm going to do something that is wrong. I'm going to wrap this in parentheses, and we're going to get a bunch of red lines, and this won't even compile. In fact, this is an intentional error that I just created. There's a type mismatch here. That's because I've tried to force the operator precedence on this by putting in parentheses, and this is saying something weird. It's saying hello world. I'm going to send an end L to hello world. It doesn't know how to do that, and this doesn't return anything sensible to go into cout. However, if we come over here and we put parentheses around this part, here, it compiles perfectly. And it runs. And it does exactly the same thing as before, because what it's doing is running this expression first, which is legitimate. It's sending the string to cout. This expression is returning a cout, a standard : cout object, which can then become this. So we can do something even more interesting with this. I'm going to use now a special keyword. This is a very convenient keyword. When you do something like this, you can go auto. And auto is just a way of saying just automatically assign the type of this expression. We're going to say audit, we're going to call this cout1 equals this. And what I'm going to do is prove to you here my assertion about this. Then I'm going to go cout1 from standard endl. And I believe we have to do this. Why am I getting... So we'll just go standard : iostream ampersand. Okay. Well, it didn't like the auto. It couldn't figure out what the type was. The type is actually this type, which is an iostream reference to an iostream. It's possible that it couldn't figure it out. All right, what is this statement saying? This statement is saying create a variable in my local space here called cout1. It's of type iostream ampersand, and we'll talk about references. This is just a reference called cout1, and assign it to the return value of this expression. Well, this cout expression is going to send this hello world to cout and return this iostream and assign it to cout1, and then cout1 we're going to send an endl2, and this will do exactly the same that the other one did. We'll run it, and there is our hello world and our carriage return. We could do something else here. We could send something else to it. We can put quote bill, just to show you that cout is really in fact sending something out. This should be the entire string now, hello world bill. Okay, so that's how this structure with these, excuse me, this is an odd thing Visual Studio does once in a while. It gets confused with C++. That this is an expression, and it can be assigned to a value. There's no need to do this way, although there might be some places where we would do this with streams, but it's not necessary. So let's just revert it back to what it originally was. All right, so that's our. We don't need the parentheses, and we don't need the auto equals. Now, one of the things I want to caution you about is this. You will see this sometimes in some people's programs, and it's this statement: using namespace, namespace std, semicolon. If we do this, we don't need to put this standard in front of here anymore, and I'll show you that this runs, and then I'm going to explain to you why you should not do this. So this runs, and it worked just fine, and we didn't have to put the standard in front of it. However, by doing this, you opened up the entire standard namespace. Every single thing that's in iostream just became accessible to this particular global namespace. This is a bad practice, especially with standard. In fact, I don't ever use using namespace at all. But you will see it in some programs, and so I want to caution you about it, that it is really not a good practice. There is a practice that you can do that is workable, is that I can come up here and make what's called a type definition. So this is a standard C++ thing. I'm going to come up here and type in type def. Okay, sorry. It's kind of late. This type def created an iostream ampersand type called my, and in fact not call it cout, I'm going to call it my iostream. Now, if I really wanted to use this cout a lot and I didn't want to type this standard all the time, I could come in here and define my own variable for cout, and we'll do that like this. We'll say my iostream OS, we'll call it, equals standard std : cout. And now I can come down here and just type OS. And I can do another one here, and I can just call it endl is of type, it's a fairly complex type, so we still need to use the endl. And I'll talk about defines. Defines can be useful. I don't like to use them too much, but we'll do a quick define, and we'll make it endl as standard : endl with no semicolon. And we'll change this to endl. All right. This should work the same. And it does. Sends out hello world. So what have I done here? Well, I've created my own alias for a type. The type that I'm aliasing is this iostream ampersand. I included the ampersand because I want this to be a reference. In fact, I could shorten this and just make it my OS, and we can make this my OS. So that's just short for outstream. I'm creating a variable of type myOS, which is just an alias for this. And I'm assigning standard.cout to that. So this is now a reference to my output stream, and it's just called OS. Now, what is a define? A define is a macro. And macros can be a little bit tricky. For simple things like this, they're okay, and they have some uses in header files, and we'll talk about that, and in blocking header files from being included multiple times, and I'll show you how that works. Basically, this is telling the preprocessor that wherever you find this word endl, replace it with standard : endl. So the preprocessor is, before this ever runs, going through here and saying, oh, here's endl, put in standard : endl right there, and leave the semicolon in place. This, however, is not replacement. This is actually in the code. This assignment's happening in the code. And I could now go down here and print out multiple things much more easily. Hi there, from endl OS, from another line, from endl. All right, and return 0, and we run that, and all three of those print out, and that just saves some typing. So, all right, so what have we covered? We've covered a little bit about output streams, header files, why then we don't have a .h on this. We covered a little bit about output stream. We're going to be using streams a lot. Streams are very powerful, and they can be used for many things. They don't have to be outputting to the console. They can be outputting to a file, and they can even be doing other things not necessarily related to files or consoles. They can be doing stuff related to memory. We've covered a little bit of define. There's more that you can do with define. You can put arguments in here that you can pass into it. I am going to teach about define and how it all works, because part of this course's purpose is we're going to be dealing with the Unreal Engine C++ coding a little bit in this course series, but very heavily in the other course series on Unreal Engine, which is a different playlist in this same channel. The Unreal Engine uses a lot of very powerful macros to make things work. And so familiarity with what these macros are about and how they work is important to that. We're also going to deal with various built-in algorithms in the standard library, other than just streams. There's many capabilities in the standard library, and hopefully at some point in time we might even get into the boost library and all that down the road. So that's it for this video. I hope you enjoyed it. And I just want to check the time here real quick. Recording time is 33 minutes. That's not too bad. So yeah, this video is complete. Hope to see you in the next video, and thanks for watching.